Our presentation today is based on the paper titled Blockchain-Based Land Record System presented at the ICAECT 2022 conference by researchers from Vishwakarma Institute of Technology, Pune. These are our group members. In this research paper, the introduction is about in India, managing land records is a challenging task due to the high population and frequent property transactions. The current system is outdated and often lead to fraud, duplication, and delays. This paper proposes a blockchain solution to make land records secure, transparent, and tamper-proof. By using smart contracts and decentralized storage, the system aims to simplify land registration while ensuring data integrity and public trust. And when we talk about the problem statement, India's current land registration system is outdated and paper-based and highly dependent on intermediaries, vulnerable to forgery and delays and manipulations. This make it hard to people to check the who owns the land and to complete land delays quickly. Because the system is not clear and open, it can lead to cheating and arguments. That's why we need a new system that is clear, safe, and easy for everyone to use. When we talk about the objectives of the conference paper, the main objective is to design and implement a blockchain-based land record system that ensures security, transparency, and tamper-proof record keeping using Ethereum blockchain and smart contracts. The other objectives are replace the current paper-based semi-digital system prone to fraud and inefficiency and ensure immutability and data integrity using hashing and digital signatures. Next objective is develop a user-friendly web portal, and in that it created two access layers for citizens and government officers, and it hoped to reduce third-party involvements and speed up ownership transfer process. When we talk about the methodology, the solution is implemented on the Ethereum blockchain, which provides a decentralized and tamper-resistant ledger. Two smart contracts are developed using Solidity, one for users with read-only access and one for admins or government officers with full access to add and update records. To make the system interactive and visualize, they use React.js to build the web portal and Google Maps API to show the land plots with predictive geolocations and polygons. All data is stored on blockchain in JSON format, which can be accessed using Web3.js via the RPC JSON protocol.
Thank you. I'm Silvagan TDRD under registration number 4219 from Department of Computer Engineering. I'm going to explain about the proposed model overview and the algorithm. When you consider about their model, they have the blockchain part. It has been divided into two sections, which is private and public, and they have two types of portals, which are for admins and for the normal users, and they have a database for government. Actually, this database is on the blockchain itself, so they don't use a separate database for their in their model. So it's a complete Web3 design. So they don't have a separate backend as well. In the public blockchain part, it can be it is used to is used for the both portals. For the users, the read access only given for the users, and for the admin portals, the read and write options are given. So they use a private blockchain part to store the official government data documents, which are they have formatted the documents into another format, and they, like JSON format, they store in a private blockchain. So let's move on to the blockchain implementation of this model. In this model, the blockchain implementation, they use Ethereum mainnet as their blockchain service. So use of the Ethereum mainnet, so they need to use the contract as the Solidity. They need to create a contract with the Solidity language, and they store data in the JSON format. All this all this data, they store all this data in on-chain. There are no separate off-chain data they only use on-chain data only. They store such as geolocation points, seller information, buyer information, and time stamps in the transaction, and the deeds where when the deeds have been created, and the agreed amount to a transaction, etc. And also they need to actually store the amount, this amount in here, as you can see, when initially they need to estimate an amount. That amount is also there, and the previous owner, current owner names, and which the land type, what is the land type, and also the land ID they have been given. Those data stored in a JSON format. As you can see, this is a transaction receipt. In this is the format that a transaction is created. And let's move to the algorithm they used. Actually, they use the default algorithm of the Ethereum itself. As we know, the elliptic curve digital signature algorithm, also known as ECDSA, is used on the Ethereum itself. So they don't use any other separate algorithm. They use Ethereum. It's the algorithm they use. As the hashing function, they use KEK256, which is a SHA-3 variant of SHA-3 hash variant. The purpose of the hashing and the algorithm is to generate a public-private key pair to make transaction and peer-to-peer connections. And also, when signing using those keys, it will be secure, and it can be verified when doing a transaction and when the deed wants to be verified. So the data format, as I mentioned before, they use JSON retrieved via RPC using Web3.js. And also in this proposed system, they use JavaScript library to communicate with blockchain nodes to remote procedure calls. Then it will make easy to pass and display the data in the front-end applications. So thank you, and I am Mr. from here, and I will hand over this presentation to my friend.
Thank you. Let's move to the results and discussion. In result, we are comparison of these two systems. In traditional system relies on paper records. This means this is leading to misleading or hampered data. Digital land records management program use digital database, but it is still open to happening some security breaches and data losses. Because of that, we propose a system which is based on blockchain. The system ensuring immutable data records and no downtime mean people can access 24/7. and higher transparency with public access. The public society can verify and see the transaction using public IDs and smart contract based verification for ownership transfer. Also, blockchain system provides synchronized nationwide access to a web portal. Anyone in the world who can log the system at any time and with a transaction. The traditional and TLRMP requires multiple authentication, but blockchain allows single body management. It means these previous two systems are basically based on centralized. But our blockchain system is basically decentralized. Let's move to discussion in benefit and impacts. This system eliminates middleman usage, means there are no any broker or agent to access these records and access these transactions. Reduce trust. Because of no third party involved in these transactions, the blockchain is secure and validate ownership and blocking tampering. Increase accessibility. Citizen can search land records by plot number and location. In anywhere, anywhere the world, the citizen can log to the system using public IDs. They can see all transactions. And this system ensuring higher security level because of blockchain is resistant to hacking, data breaches, and also downtime. Also, this system is open to scale with the needs. Thank you, and I hand over this presentation to Ashley.
I will now summarize the key limitations and conclusion presented in the conference paper titled Blockchain Based Land Record System. The authors have acknowledged several practical limitations in implementing their proposed blockchain based solution. One of the major challenges in the lack of access to official government databases, which restricted the scope of real-world testing. Without actual land register data, the system could only be validated through prototypes and simulations. Additionally, the paper highlights a significant technological gap among registry officials. Many government personnel are not familiar with blockchain systems, which poses a barrier to adoption at the institutional level. The success of this solution is also still depend on government support and integration with legacy system, meaning that without policy backing and infrastructure changes, deployment remains theoretical. Another limitation concerns the scalability and cost of using the Ethereum blockchain, particularly the high transaction or gas fees, which could make the solution less practical for large scale or frequent use. Finally, rural connectivity issues and limited awareness among landowners may hinder the system's accessibility in the areas where it is most needed. Despite these challenges, the paper concludes blockchain technology holds strong potential for transforming land record management in India. The system offers transparency, immutability, and tamper proof storage, which are essential in reducing fraud and disputes in land ownership. By automating legal checks through smart contracts, the system enhances trust and reduced reliance on intermediaries. The authors envision a future where this solution could be extended to include cryptocurrency transaction, 3D asset registration, and even AI-driven validation of land records. Overall, the paper provides a comprehensive case for the application of blockchain in public record system and supports land's digital transformation agenda. Thank you for your attention.